you ever stare at a list of numbers and just feel lost? Like you're totally missing the point? Well, think of that data as a collection of clues. And a graph? A graph is the magnifying glass we're going to use to solve the mystery and find the real story hidden inside. So, let's get into it. Every good detective story needs a puzzle to solve. And ours, well, it starts with a simple set of numbers from a basic science experiment. And here it is, our big question. What story are these numbers really telling us? I mean, right now, they're just numbers on a page. But trust me, by the end of this, you'll be able to read them like a book. Okay, so here are our clues. This table shows what happens to a spring's length when we start hanging different masses on it. I mean, you can see the numbers are going up, sure, but the real pattern, the relationship between the mass and how much the spring stretches, it's still kind of fuzzy, right? We need a better way to see what's going on. But before we can build our graph, we've got to know our tools. And in science, the most important tools for understanding experiments are something called variables. So let's break that down real quick. So what even is a variable? It's really simple. It's just anything in an experiment that can change or that we can change. You can think of them as the moving parts of our whole scientific story. And in this story, there are two main characters. First, you have the independent variable. This is the one that we, the scientists, are in control of. In our spring experiment, we choose what mass to hang on the end. Then you have the dependent variable. This is the one we measure. It's the thing that responds to whatever we changed. The spring's length depends on the mass we add. Get it? All right, we've got our clues, we understand our tools. Now it's time for the fun part. We're going to take these abstract numbers and turn them into a clear visual picture. Let's build our very first graph. It's really just a simple three-step process. First, we'll draw and label our axes. That's kind of like our canvas. Then, we'll plot our data points, placing all the clues on the map. And finally, we'll reveal the hidden pattern by drawing what's called a line of best fit. Step 1, the axes. Now, this is absolutely crucial. The independent variable, the thing we changed, which was the mass, always goes on the horizontal x-axis at the bottom. The dependent variable, the thing that responded, the length, goes on the vertical y-axis. And now for step 2, plotting our clues. Each pair of numbers from our table becomes a single dot on the graph. So for example, we saw that a 5-gram mass gave us a 14.1 centimeter length. So we find 5 on the x-axis, go straight up to 14.1 on the y-axis, and bam, we make a dot. And we just do that for all of our data. And finally, step 3. Now, we don't just connect the dots like a kid's puzzle. No way. Instead, we draw one single straight line that gets as close as it possibly can to all of the points. This is our line of best fit, and this is the magic that reveals the hidden relationship in our data. Okay, the graph is built. Our picture is complete. Now it's time for the big payoff. What story is our graph actually telling us? Let's find out. And just look at that. The pattern is crystal clear now. Our line of best fit is a perfect straight line, and this has a special name. It's a linear relationship. It tells us a simple but powerful story. As the mass gets bigger, the spring's length gets bigger at a nice, steady, predictable rate. More mass, more stretch. The graph just makes it so obvious. But, science isn't always that neat and tidy. Sometimes the clues don't line up in a perfect straight line. So let's take a quick look at some of the other kinds of stories that data can tell. So check this out. This graph shows how far a ball falls over time. It's definitely not a straight line. It's a curve. This is called a nonlinear relationship. It tells us the ball is falling faster and faster, and that beautiful curve on the graph perfectly captures that story of acceleration. And here's another cool plot twist, the inverse relationship. This graph shows that as a car's speed goes up, the time it takes to go somewhere goes down. It makes sense, right? When one variable increases, the other one decreases. It's a totally different kind of connection, but the graph makes it just as easy to see. So we can see patterns and we can understand relationships. But this is where graphs become a superpower. We can actually use them to make predictions, to see beyond the data we actually collected in the first place. It's a bold question, isn't it? Can a simple graph that we drew actually predict something we haven't even measured yet? Well, let's jump back to our spring experiment and find out.
You see, that straight line we drew isn't just a picture, it's a mathematical rule. And it can be described by this simple equation. You can think of this as the secret code we cracked from our data. Just remember, y is our dependent variable, the length, and x is our independent variable, the mass. So, let's put it to the test. What if we wanted to know the spring's length for a 49-gram mass? That's a value we never even measured. It's simple. We just plug the number 49 into our equation right where the x is, and then we just do the math. And boom, there's our answer, 18 centimeters. Just like that, our graph has predicted the result for an experiment we never even ran. We used what we observed in the past to literally see into the future. I mean, how powerful is that? So let's just sum it all up. Why do we even bother turning numbers into graphs? Because they let us instantly see patterns that are buried in boring tables of data. They help us understand the relationship between our variables, whether it's linear, nonlinear, or inverse. And what's most amazing, they let us predict values we haven't even measured yet. So we went from numbers on a page to a visual story with predictive power. That's the amazing journey a graph can take you on. So the next time you see a set of data, don't just see the numbers. Ask yourself, what's the story hidden in there, just waiting for me to graph it?